Hello everybody, I'm Nick, and in a previous video I talked about a brand new feature coming in C# at some point in the future called discriminated unions, and it's actually the most requested feature of C# really ever, and they're more appropriately named type unions. And one of those points in that proposal that we read is that there's two native types coming in the runtime, and that is the result type and the option type. And many people are very confused as to what those are, what they do, how are they going to work, and why are we getting them in the first place. So in this video, I'm going to show you what those types are, how they work in other languages, and how they're likely to work in C#. Now, this is something you can actually do already through NuGet packages, and Microsoft is addressing that in their Q&A, which we will, by the way, take a look at after I show you the feature. But I personally think the fact that they're being added is a net positive, because if someone wants to use them, they will use the runtime version part of the BCL, so everyone will have the exact same common type. And this will become very, very powerful for consolidation of libraries and NuGet packages. So let me show you what I have here. I have a simple console application, and I have this user service over here. So all I really have here is I'm trying to emulate something that is maybe calling a repository, or it's calling a DB context in Entity Framework Core. But the idea is I have some sort of database, in this case in memory, and then I have a get user method that returns a nullable user, trying to find it based on the ID. And then I have a create user method where we have the email and the name, very simple model. We pass the email, we try to validate it. If it's invalid, we throw an exception. Hey, you just used an invalid email. Then I have a check on the database on the email, because that's my unique identifier for this example. Hey, if it already exists, then we throw an exception. And in the end, if everything is good, we create a new user. Very simple. And those exceptions are validation exceptions. So if you want to try catching a validation exception and then get the message, you can, and you get a message out of it. This is extremely common code. I see this all the time in many code bases. Now in the program.cs, I'm going to simulate how this is supposed to work from a consumption standpoint. So first you would have your user service. And if I want to create a user, I would say user service.create user Nick Chapsas. And if I went ahead and I tried to create the same user twice, the first one will create it, but as you might assume, the second one will throw an exception. Hey, this email already exists. User with email nick@dometrain.com already exists. Makes sense. Now, I could also just get the user, and because this is a nullable type, I'm using a user nullable over here. I can say if user is null, then, user does not exist, throw a message. But it also means that if I try to do something like console.writeLine, the name is, and let me just quickly fix that, the name is user.name. Well, I have these yellow squiggly lines telling me that there's a possibility for a null reference exception, because we don't really know if this user actually exists at this point, because this can return null. This is a nullable type, so you might want to add an if check. And we can easily do that by potentially checking the expression for null. So if the user is not null, do that, and so on. Now, something you might have noticed about this feature is that it isn't actually an error. It is just a warning, even though we know for a fact that this can return null. Many languages actually treat this as an error. C#, because they introduced this feature in C# 8, they couldn't just go ahead and turn this into an error by default, because it would break a lot of code bases if you want to adopt the feature. So they made the warning. I think that's bad, because it sort of kills the purpose of the feature being there in the first place. So what many people do is actually they turn this warning into an error. And if there's a warning like this that turns into an error in the code base, then you can compile, and they go ahead and they address it. And this will actually make your code base way more robust. So that is one of the problems. But the other problem is that we now have to throw these exceptions that we later have to catch. So we have to say catch validation exception. So validation exception over here, then try to create the user. And if the user hasn't been created, we catch the exception, we get the message, and then maybe we return a type. Which means that if I have something like an I result, because this is an API and I'm trying to return an HTTP response, for example, well, what I have to say here is, well, take this, then get HTTP response. Then I'm going to try to create this local function over here, and I'm going to say, try to create it, pass it down over here, var created is this, which returns results dot created normally, but I want to prevent the URL. So I'm just going to say create it to return an OK. And then I'm going to say return results.bad request. I'm going to pass down the message very, very quickly. And then I have my HTTP response, which your map get, map post, map put, and so on are going to use. Now, this is all fine, but first, exceptions are incredibly painfully slow, and using them like this to control the flow of the application is, in my opinion, a very, very bad practice. And this is actually a very common criticism of exceptions used in that way. And of course, you have the nullability aspect, which isn't actually really enforceable, because even if you enforce them in your own assembly, whoever else is consuming it doesn't have to actually use them. And that's where option and result come in to fix both problems. But before I show you that, I want to let you know that we just released 2 brand new courses on DOM training from Zero to Hero, Git, and GitHub Actions. Those 2 courses are authored by Scott Sober, who has incredible experience in both topics, and they both take you from knowing nothing about the topic into some really, really advanced stuff. And what I loved about those courses is that they both show you what happens when things go wrong and how to fix it. Now, until the 18th of August, you can buy the GitHub Actions course and you will get the Git course for free. Link in the description. Now back to the video. So what is that result and option type? Well, I'm going to go on NuGet and I'm going to install languageextensions.core, a NuGet package called languageextensions.core. Why? Because that language extension package adds functional elements, and those 2 types are technically monads, even though I'm not going to actually talk about monads in this video, but they add those types in the code base in at least one of their flavors. Now, the way they're going to work in the runtime when type unions are actually added is going to be a bit different because the experience of consuming them will be way, way more elegant. But I'm going to try and show you the idea behind them. So let's say I wanted to change this to use one of those 2 types. Well, what you would use here is you would use an option type. So you would say not user, but this returns an option of type user. What is an option? Well, an option is a discriminated union type which can have one of 2 states. It can be some value of a specific type, or it can be no value. Conceptually, you can think of it a bit like nullable type of type T, but the difference is, and we see that with both cases, that in order to lead to safer code, you have to handle both outcomes. There's no way to try to get out of handling both scenarios. And that's the whole idea of discriminated unions and type unions. You have to deal with both scenarios, or as many scenarios as there are. The other thing is the user. This user can have different outcomes. It can have successful states and failed states. Well, what you need to have here is not a user, but a result of type user. And as you can see, by the way, here, nothing really changed. This is exactly the same from the way I implemented this. This returns a nullable type over here, but that is automatically converted into an option through an implicit conversion. And that's the same for the result. Over here in the user, I didn't have to say new result of type user. The user is converted into a result automatically. However, the exceptions now are turned into what we call errors in a result, because a result can be either a success or an error, a failure basically. And the failure is represented in this implementation using an exception. And in order to change my code base to accept this, I'm going to say return new result of type user, but we actually return an exception which automatically turns it into a failure. And I'm going to do the same here, return new exception, and that's it. So now we have my user service changed, and I know many people already hate this because now they're like, okay, why am I returning this? But trust me, you will write safer code by doing this. Now let's change the existing code we had to use these new types, and I'm going to start with the nullable aspect of it. As you can see now, I can no longer say this is a user because it's not a user. It is actually an option of type user. Okay, but if I turn it into an option, I can no longer use the name. How am I supposed to get the properties of that user? Well, you can't. What you can do is you can try to switch on that object and handle both of these situations. You are going to have to exhaustively handle both scenarios. Now, there's many methods that you can use here, but the one we actually are going to get in C# is you'll be able to switch on this and say that if this is some value, do this. If this is none value, do this. The way language extension does it is we have to say much, and we have to match both scenarios. So if we have some value, then we have a user. And if we have none value, then we have nothing. And we need to handle both situations. Now, this looks ugly because it doesn't really fit the language in its current state, but eventually this will be a switch and it's going to be pretty. But what this means is I can go ahead and say that, hey, if a user exists, then now I can access the user object. And I can say name over here, and the name is this, or the user did not exist. And that's it. And now if I was to run this as it is, of course, we are creating the user here, so that should not be a problem. I should just see the name is whatever. So my code will work exactly the same. However, if I try to get a user that did not exist, so Nick A, then as you're going to see, the user did not exist. I'm handling both situations very, very elegantly. Now, of course, this would be way prettier if we had the switch, like I said, because that then would be you is this, and you'll be able to handle it like something like this. And if it was none, you would have something like this. So you'd be way closer to this experience than any other experience. And I think this looks pretty nice. Now, option types also have different approaches to this. You can actually say that user option dot if some, then you can have just the happy path handling. So you can say, hey, if there is some value, then do this. This is way more functional than what most people are used to in C#, but you can do that. And then you can also do the same with if none. We don't really know if those things are going to be added in C#, but those are things that you can do currently with language extensions. If I just revert to the previous state with the match, then I'd be able to show you what's now happening with this approach. So now we no longer have all that going on. If I want to get an I result, I don't need a method to begin with. I can simply say that user service.create user, and actually I'm going to turn this into just the result. And remember, this type explicitly is result of type user, and that can only be success or failure. So I can say I result of HTTP response equals result.match. Same thing. I can also map, but I'm going to use match here. So if it is a success, I'm going to say return results.OK with that user. If it is an exception or a failure, I'm going to say results.bad request and then exception.message. Here we go. Very easy, very simple. This can actually become even prettier. Here you go. And now I have all that code turned into this, and I do handle both situations. I have to say that if something is handled correctly, here's my response. If something is not handled correctly, then that's how I deal with this. And I don't have to throw exceptions. I can just propagate that if I don't need to use it, or I can simply handle it when I need to handle it. I think this is a great addition to C#. I really hope this is being added. And I do want to take a look at the Q&A because Microsoft has addressed this in the proposal. So why do I need the option type if I can do the same thing with nonce and null reference types? Well, the answer is you might not need the option type at all if you're comfortable with using nulls for the same purpose. However, some developers prefer the option types as it has stronger enforcement. It is all about enforcing the usage and the consumption through option. It's not something you can turn off. You have to handle both things. That's where the power is coming from. And then again, why do I need the result type when I already have exception handling? Many of the use cases for the result type are solved by using exception handling in C#. However, you may prefer to avoid exception handling, which by the way is very expensive in terms of performance, and require the caller to deal with errors explicitly where errors are unexpected and occur commonly at runtime. It's a way better experience. I've seen this used all the way back in 2017, actually, is when I first saw these result and option types used in a production code base when I first started work at a massive company here in the UK. And they work. They do actually lead to a better code base. They do have quite a bit of a steep ask to start using them and understand them. And because they're not part of the runtime, there is a level of training you need to do for your developers to actually understand them. But once they do, they work wonders. And then again, in the end, If we have them already in third-party libraries, why are they being added? Well, they're being added because we want to standardize them and have interoperability between libraries. I think it's a great feature. I'm so happy Microsoft is adding it, but I do want to know from you. What do you think about this? Please leave a comment down below and let me know. And Microsoft is watching these videos, so any feedback you have will also be taken into account by Microsoft. Well, that's all I had for you for this video. Thank you very much for watching, and as always, keep coding.